No, Commissioner. Enough's enough. I'm bloody sick of it. Bat Dog and I have got work to do. Why don't you ring bloody Brian? He'll just be sitting on a BMW watching his cricket. Yeah, well, of course he'll be pissed. No, that's why you pay those fat donut-eating buggers. No, I'm busy. Bye. G'day everybody and welcome to Basket Case. Well, we finally dispensed with that clown. This pile of junk sitting on the bench in front of me represents all of the components, or most of the components, that will make up the braking system for Basket Case. Most of it came with the original bike, and some of it I've picked up along the journey as second-hand bits. And I'm going to try and fashion it all now into something that might actually bring the bike to a stop. And I think I'll start with the rear master cylinder. Okay, I'm going to start with the back master cylinder. Now, I had two, and this one here I cleaned up. I've painted this, but it was pretty good. It was sealed. It still had oil in it, which is a good sign. The bore was a little bit gangrenous, had a bit of oxidisation, a little bit of rust, and I gave that a bit of a quick clean up just using some 2000 grit wet and dry paper. I cut a bolt, put a slot in it with a hacksaw. Let's take this apart and show you with a hacksaw, and just wrap some wet and dry on there for some lapping paper, and a bit of CRC, and gave it a good little hone. So that's come up fairly nice now. I'll just give you a look in there. It's nice and smooth. It's still got a few stains in it, but it's pretty good considering, and it will be fine to use. Now, quick tip about master cylinders: if I shine, looking down that hole there, if I shine a light up through the bottom, you'll notice there's two holes in there. Pretty sure you can see both of them. One is a large hole, which is the hole that's used for refilling the chamber, and there's a smaller hole in there, it's less than 1 millimetre in diameter, and that's the vent port, called by many names, but this Society of Automotive Engineers, SAE, deemed it worthy to call it a vent. So the idea, as he sits down in there, that's the bottom hole of the two that you can see there. If he blocks up, it doesn't allow the pressure to release from your brake, and you end up with a locked up brake. So if that's a symptom you're having, you need to get a guitar string or something and clean it out. The steel guitar strings work well. So anyway, I'm going to be resurrecting this using second-hand parts because I don't have a kit for the rear cylinder. I've got everything I need here. Like I said, everything's been cleaned, it's been painted, and the buckets have been curing, or I've been prepping them by sitting them in brake fluid, and they're nice and malleable now. You need to rest them for about 15 minutes in the brake fluid. So what we have first of all is un spring, and there's a little cap that goes over there. You just sort of gently work the buckets in, so you get them started in the bore, and we pop in washer and the circlip. Just check that circlip. Just radius side down, flat side against the load side, the groove. A little bit thumbs tonight. Pop the circlip down in there and make sure that it's seated. Right. Good day. So that's that part done. There's also a rubber boot that needs to go on. Try and keep the road muck out of the system. Alright, so that's the piston assembly. This guy, I've also got a little bit of lube on. You just got to be careful that you don't get brake fluid everywhere. The stuff's toxic and it will eat paint. It will eat your clothing. It's a polyethylene glycol mix. And it's highly toxic, so if you're disposing of it, you need to make sure that you do that responsibly. Alright, so when this mounts on the bike, it mounts thusly, and I need to be able to read the level indicator, so this guy can go on there. Push him down into the O-ring. Right, it's a little bit proud, but that'll pull down with the cap. There is also a plug that blocks off the end of this bore here. Just need a 14mm spanner for that. And then there's a cap with there's a rubber seal. This rubber seal is a little bit knocked around, and it's also looks like it might have been put on there a little bit not so carefully at some stage. You just got to be careful that they sit down over those plastic bosses on the lid, because what you don't want is holes like that where you could potentially have fluid leaking out into the, or more importantly, getting moisture in there. Yes, just got to make sure they're all down, and they are, and pop the cap on. So that's ready to go, and I obviously need to put fluid in it, and I'll be putting this together with the master cylinder and bleeding it before I mount it on the bike. Alright, so I just wanted to give you a quick rundown on what makes up the rear master cylinder. Like I said, there's not a lot in them. Let's have a bit of a chat about them. Okay, we'll try and keep this as interesting as we possibly can, I guess. Want to start the talk about brake fluid. There's different types on the market that are available. You'll hear expressions like DOT3 and DOT4, and if you're ever wondering what that is all about, DOT is an acronym, D-O-T, for Department of Transport. And it's the US Department of Transport, so there was a set of standards that were put in place many moons ago to determine what brake fluid composition was going to be and have it out there safe for the public in their vehicles. So it's essentially the 3 and 4 that you'll see refers to the boiling point. So DOT3 has there's two, and when they talk about brake fluids, there's two different types of boiling points. One is a dry boiling point, and one is a wet boiling point. Now, the dry boiling point is essentially brand spanking new fluid in a sealed container, or it's been taken from a sealed container and put into a system. So it has little to no moisture in it, because this stuff, this polyethylene glycol, is what they refer to as hygroscopic, which means that it will absorb moisture and it'll do it out of the atmosphere, and it does it very efficiently. So dry boiling point and wet boiling point. The wet boiling point refers to, well, they had to draw a line in the sand, and they said at 3.7% water per volume is what we're going to measure as the wet boiling point, which means that it's absorbed water essentially out of the atmosphere into the fluid, and at 3.7% water per volume is what they're calling the wet boiling point. So for dot 3, the dry boiling point is 205 degrees Celsius. Now, if you're watching in black and white, it's 401 degrees Fahrenheit. And if we go then to the wet boiling point, so after the fluid has aged and it's had some moisture get into the system, the boiling point drops quite dramatically to 140 degrees C, which is 284 degrees Fahrenheit. And no, I don't have a photographic memory. I actually had to look up these Fahrenheit conversions. So that's dot 3, and when you consider water boils at 100 degrees Celsius, that 40 degrees isn't a whole lot more. We go to dot 4, and dot 4 has a boiling point of 230 degrees C, and which is 446 degrees Fahrenheit, and it has a wet boiling point of 155 degrees Celsius, which is 311 degrees Fahrenheit, which is a marked improvement. You can buy up-spec versions. I think they have some sort of bore, I can't remember what they put in them, but this is a Super Dot 4, and it has a dry boiling point of I did read it here somewhere, 280 degrees Celsius. So that's, you know, even better again, and that's what I use in my Ducati. So yeah, that's what all that's about. There are some hydrophobic, which means that they don't absorb moisture, fluids on the market from people like a Rolls-Royce, and very expensive stuff, probably out of the reach of you and I. So we're sort of going to go down to the local auto parts supplier, and we're going to purchase a brake fluid that is a dot 3 or a dot 4. My preference is a dot 4. I think most vehicles will specify if they need a dot 4, and you know, if you've got some ABS systems that will generate a lot more heat, or motorcycles where the manufacturer believes that there's going to be a great more of aggressive braking on that particular type of bike, then they might specify a dot 4. Personally, for me, I'll always buy it. So where does the heat come from? How do we boil it off? Well, of course, we have friction at play. So we have a motorcycle which is at rest and has a mass of about, let's just pull figures out of our head here, say 200 kilos. Probably more than that by the time you put a rider on there and what have you, and full tank of fuel. We want to accelerate that bike up to highway speed. So let's just say, for example, and these are purely figures I'm just pulling out of thin air. Just say we need 50 kilowatts of power to accelerate that bike from rest to 100 kilometers per hour. Ergo, if we wanted to bring that bike back to rest again, back down to zero, we would have to apply 50 kilowatts of power to bring it back down to rest in approximately the same time. So that energy that we apply, that 50 kilowatts of friction energy, is transferred into heat, dissipates mostly out through the wheels and the caliper. The disc rotors out into the air and is cooled, but a good portion of it is put back into the fluid and it heats up. So let's have a look at. So it's probably enough, I guess, waffle about brake fluid. But we need to talk about master cylinders, which is this guy, Brian. So the oil will sit in this reservoir and it floods into a chamber, and we have a piston that operates up and down in here, which we saw during assembly. So that bore, that cylinder that the piston operates in, sits thusly, and inside there we have our primary piston seal, which is a cup seal, and he's attached to a piston, and in the case of the XS1100 and a lot of other motorcycle master cylinders, there's a second cup seal, and the piston then extends. There's some way of retaining the unit, in this case a circlip, inside the chamber so it doesn't fly out, and we call that assembly the piston assembly. And on the other end of it we have a spring. And the spring's job is to bring the piston back to the rest position. The rest position is very important. On the back of the piston assembly, you'll have a plunger, some method of depressing it, and there'll be a brake pedal somehow fashioned onto it. And it's important that you have free play set at that point where the plunger meets the piston, and I'll explain a little bit more about why later. So essentially, when we talk about hydraulics, we are technically, hydraulics is water-based systems, but since Archimedes, there's been a lot more discoveries, and people have developed a lot better products than water for these types of systems, which water would be next to useless. And so we've got fluid of some type anyway, and in this case it's brake fluid, sitting in our master cylinder, and it's plumbed to a caliper, a brake caliper. And our brake caliper contains a piston. Thusly. Sitting above our cylinder here, we have the reservoir for the fluid, which sits up here. Now this particular one's cast as part of the assembly. Some of them are remote mounted and have a hose going down, but all systems like this will have a reservoir, and they have a replenishment port that in the rest position sits behind the bucket. In fact, during the whole operation it sits behind the main cup seal. So your fluid sits in here inside the reservoir, and it is completely flooded in the chamber, and through the pipe or hose. Because we've got a swing arm and a set of forks, we need to have flexible hoses running down to them. So that whole system is chock-a-block full of fluid. And this cup seal here just works as a piston pump. So it travels through the fluid in that direction, and as it does, the fluid pushes out onto the edge of the cup seal and helps to create a seal between the cylinder wall and the piston. Then when the piston assembly is travelling back again, the oil is able to escape around the top of the cup seal, so it just moves back through the fluid. and it just works as a piston pump, boop, 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 just pushing a volume of oil that moves back and forward. On the other side of the piston is that small compensating port, or as the Society of Automotive Engineers have deemed to call it, the vent port. Now, when the piston first starts to travel, the cup seal will pass that vent port, and the minute it does, you start to build pressure in the system, because it's now completely isolated. Once it's in this position here, it's travelled forward. It's completely isolated from the reservoir. The oil that's in the back here will just move, very much just move up and down, or you won't even notice it's that minuscule. But this area here behind the main working seal just remains at reservoir pressure. Whereas on this side it's the high pressure, so you're pushing the oil in that direction and it all moves through the system up to the piston. Now, Pascal's law states that if we have a non-compressible fluid in a confined system, such as this, where it can't escape, and we apply a force, that force will be exerted in all directions in that system evenly and undiminished. So whatever we apply here will be pressing on the walls of the tube, on the bottom of the piston here, inside the tube, and on the seal itself. So that force that we apply is undiminished and even right throughout the whole system. So that means that ideally, you'd have a solid steel pipe here, because you get no reaction from the force. Whereas with rubber tube, etc., you can get expansion, and that can absorb some of the energy that you should be putting into your brakes. So we know that whatever force we apply here is going to generate elsewhere. But manufacturers are clever, and they build in a force multiplication where you have a smaller diameter. This is only about 1/2 inch diameter bore in here with these little cup seals, and it doesn't take a lot of energy, a lot of effort to make that move inside there. And we need to be able to apply quite a bit more pressure to our brake rotor, which runs through here. And our piston and brake shoe sits in there, and another brake shoe sits on that side. It has a clamping force. So in order to do that, what they do is they build a bigger diameter at this end. So this larger surface area has the same amount of force acting on it, but instead of acting on a little 1/2 inch piece like in our piston here, it's acting on a much larger area, and that generates greater force at that point. Pressure is the same as here. Force is greater because it's multiplied across that face. That means you put a little bit of energy in here and you get a better result there. Because it's a volume of oil that we're shifting, and this is a bigger diameter, the distance that we travel here will be greater than the distance that we travel here for the same input. But what it does do is it transfers that into a greater force. I hope that makes sense. So now we've got a high pressure side and we have a reservoir pressure side, and we're keeping the oil from leaking out of the bottom of our piston with our second cup seal here. And we release the brake. So what happens then is the spring reacts and pushes the piston back to its rest position in between those two ports. And the minute it passes this compensation port or vent port, the pressure in that system equalizes with the reservoir, so it lowers and allows that to relax. And you only need a gnat's hair clearance on your disc rotor, and you no longer have friction. So that will probably sit just off there. If you've got discs that are aren't parallel anymore, they're warped, or you've got a wheel bearing that's flogged out, you get what you call brake knockoff, where the disc will actually smack piston back down into the system, and of course the oil will just return into here, and then you have a massive gap. So next time you go to put your foot on the brake, you've got to take up all that clearance, and you may, if you need 1-2 pumps, that means that your piston is travelling back too far. Okay, we were going to talk about free play. Now it's very important that you set the free play so there's a gap essentially between your whether it be your brake lever or your rear brake pedal and actuator. There will be some sort of an air gap between the two, and the reason for this is that rest position is very important. So that main seal needs to come back past that vent, and it's very close to it in the rest position. So if you put any weight on this, and people, well, my brakes aren't working right, I'll adjust them up. It's the worst thing you can do, because you'll cover or block that vent or move in front of that vent, which means that the pressure in this side of the system can't release and it equalise back with the reservoir. So the brake stays on, it drags, and the hotter it gets, the more it expands the fluid, the tighter it grabs the disc rotor. So that's what can cause that problem. That and a blocked port will cause a dragging brake. So it's very important that you set that gap. And it also allows for, as this increases in temperature through use, it allows for thermal expansion, linear expansion of the piston assembly and everything else, and that gap will close up as it gets hotter. So it's very important that that's set as per the factory recommendations. All right, well, I hope that was useful to someone out there. The next part, which will be a whole lot of woe part 2, we'll be putting it all on the bike. So I've got to get the calipers sorted, the front one's completely cleaned up and new kits through them, the rear one just basically cleaned up and put back together. And on the bike, ready to go, stopping. So before we get this thing moving, we need to make sure that we can stop it. Just getting it on and off the lift, actually, is a bit of a challenge without brakes. So thanks for watching. Stay tuned, and we'll be back for more with Basket Case. But something struck me as a bit strange whenever I tightened the rear axle, the back wheel wouldn't turn, so I suspected I might have had some issues with bearings, and that's what's come out of it.